All right, kids, we're going to look at the 2.3 lesson today. A lot of algebra still here. The top two problems are openers. So whenever you see this, like this line down here going across the paper, top two problems are usually openers, something we'll do at the beginning of class, often based on previous knowledge or previous stuff we've done in class. Sometimes it's leading into what we're doing today. It might be new, but usually it's stuff you can do. So if you want to try to do these first two problems yourself, there's really just practice and check on the answer in a moment. I'll do one of them here. Second one I'll probably just give an answer. Okay. So find in point slope form an equation of the line containing the point 2, 1 and the point of intersection of the graphs of this. So I hope you realize, we have to find the intersection of these two things here. And there's a couple different ways of doing this. I'm probably going to use the substitution method. This equation here, if you move the y over, would become y equals 3x minus 3 if I would isolate the y. And then I'm going to take that and stick it in there. So I'm going to rewrite the second equation as x plus 2, but y is now 3x minus 3. I'm going to do a little distribution. And what do I get? Combine like terms, move the 6 over. I got x equals 3. Obviously, you got to plug back in. You can do that mentally to find y. 3 times 3 is 9. 9 minus 3 is 6. So we have a point of intersection of 3, 6. And we are supposed to find the equation of the line in point slope form between that point that we just found, 3, 6, and 2, 1. So we need to find the slope, change in y. 6 minus 1 is 5. 3 minus 2 is 1. So you get a slope of 5. Now it doesn't matter which point you pick. I'm going to pick the second one. Y minus 1 equals the slope x minus 2. And I'm done. Now, I could also have picked the first point. Y minus 6 equals 5 times x minus 3. Either one's okay. Now remember, it specifically said point slope form here. So, to get full credit, you'd have to leave it in point slope form. You could solve for y and change it to slope intercept form, but that's not what this problem was asking for. Okay? This one here I'm not going to do. You can check my solution sheet for a fully worked out problem if you like. Okay, it should be fairly straightforward. You're solving a system. You do have some fractions in there, but you should get an answer of 8, 11. Okay. Now down in here, this is where we're kind of doing our new stuff for the day. This is the important stuff, and make sure you're paying attention. I'm sure that some of you have, a lot of you have done this before, but some of you maybe have not. So we're going to talk about 3 things of a triangle. We're talking about altitude, median, and perpendicular bisector. So altitude, I'll use lowercase a. Altitude, make some notes over here, has to come from a vertex. And it is drawn perpendicular, that's the perpendicular symbol, that upside down capital T, perpendicular to the opposite side. All right? So in this triangle, if you were going to draw an altitude from point A, that altitude would look roughly like this. Okay? All right? I want you to realize that every triangle has 3 altitudes because you could draw one from each vertex. This one from here would be roughly like that. I'm not going to draw it because my diagram is going to get too messy. And then, from here, looks like it'd be roughly like that. So each triangle is 3 altitudes. Now, sometimes students get a little bit confused with when the triangles are obtuse, like down here, how do you draw an altitude from A to this opposite side that's perpendicular? Well, you can't draw it to that segment. You would actually have to picture extending that opposite side, and now you can drop the altitude in there. So in an obtuse triangle, some of the altitudes will lie outside of the triangle, okay? They're not always going to be in the inside. So that's how you handle that. And sometimes the altitude could actually be, like, look, this triangle looks like it's a right triangle. You couldn't assume that. You'd have to be told, but let's say it was, okay? That means that this thing here is the altitude from A because it is perpendicular to the opposite side. This would be the altitude from this vertex. So the altitude could be inside the triangle, it could be outside the triangle, it could be a side of the triangle. All right. So median is also from a vertex, and it is to the opposite side's midpoint. Okay? So in this first triangle that we were messing with before, if you were to draw a median from A, let's just wing it with the midpoint. Midpoint looks like it's going to be about there. So, I'm going to move this A over. So that was my altitude, and this is my median, okay? Because the median's going to the opposite side's midpoint, the median's always going to lie inside of the triangle. For example, there's the median for this one. From here, I'm not going to draw on all these. You can look at my answer document. All right, median's always going to be inside the triangle. Last one, what color do we want to use here? We'll use purple, huh? Perpendicular bisector, that's going to be a combination of both, right? So it has to be perpendicular and through sides midpoint. But because it's perpendicular to the side and it's through the midpoint, it doesn't necessarily come from the vertex. It comes from anywhere. In other words, if you're going to have the perpendicular bisector in this first triangle, it has to go through that point because that is the midpoint, and perpendicular would look something like that. So there is the perpendicular bisector. Same thing here. Okay. Obviously, a triangle has 3 perpendicular bisectors. It has 3 medians. It has 3 altitudes. All right. Now, what we're going to be messing with is we're going to be doing equations of this stuff. So we're going to be applying this to coordinates, that sort of thing. Now, I have this, on number 2, I have a grid over here that you could sketch this out if you choose to help you create a visual. It's not necessary, if you really think about it. It says find the equation of the altitude from C. If the altitude is from C, it has to go to the opposite side. So that means it goes to AB, and it would have to be perpendicular to AB. So let's go ahead and find the slope of AB. Slope of AB would be what? 5 minus -6 would be 11. -2 minus -1 would be -1. So we have a slope of -11. Now remember, that's the slope of the side AB. So the perpendicular slope would be the opposite reciprocal. That would be positive 1 over 11. Excuse me. Now, we're almost there, right? To come up with an equation of a line, you need a point and a slope, or you need 2 points, because if you have 2 points, you can figure out the slope. So it says find the equation of the altitude from C, so that we know that point, and we just found the slope. Now that's not a special point, that's just a plain old point. It's not the y-intercept or anything, so I'm going to use point-slope form. It doesn't specify the form of the equation. It doesn't say slope-intercept, so point-slope form can really be our best friend. We're actually done right there. Could we solve this for y and change it to slope-intercept form? Of course we could, but why would we? It's just not necessary. Not necessary. No need to make extra work. If you understand how to do it, that's good, but you certainly don't have to do it. So number 3 on the back, again, there's a grid here as well, but the grid isn't necessary. So remember, perpendicular bisector comes from anywhere. It's got to be perpendicular and through the midpoint. So maybe you try this one yourself if you haven't already. You know what I'm going to do first is I'm going to find the midpoint of KL. So that means we want to average the x's. 8 and negative 1 is 7. So the x value, the vertex is 7/2, and the, you know what, the y value comes out to 7/2 as well. So we have a point. Now we need a slope. Now remember, perpendicular bisector of KL, so it has to be perpendicular to KL, so let's find the slope of KL. 9 minus negative 2 would be 11. Negative 1 minus 8 would be negative 9. So the perpendicular slope would have to be positive 9 over 11. Again, it's asking for an equation. It looks really ugly with this fraction, but with point-slope form, it's no big deal. Y minus 7/2 equals 9 over 11 times x minus 7/2, and we're actually done. Yeah, that would be kind of a pain, a little bit of a pain to solve for y, but remember, if it doesn't specify form of the equation, you could leave it in point slope. If you know the y-intercept, I would do slope-intercept form. It's pretty rare that you would ever do standard form. We don't use that too often. Okay, this next one's going to involve a little bit more thought. We're given the coordinates of a triangle, but we don't know the full coordinates of C. So we're actually to find the value of y. But we're also given some other information. We're given that the equation of the median from vertex B is this. Okay, so the median, let's see, what can we do with that? The equation of the median from vertex B, that means from vertex B, it has to go to the midpoint of AC, right? So midpoint of AC. Let's see, what's that going to be? Well, negative 3 and negative 5 is negative 8, divided by 2. 7 plus, well, we just have y plus 7 over 2. And that's okay. So remember, we have the equation of the median, and we know that the median has to go through this point. So now we can just take this point and put it in for our x and y. So y, this is our y value. So y plus 7 over 2, that goes in for that, equals 1/4, and there's my x value. And there's the rest of the equation. So this is going to be what? Negative 1 plus 4 is 3. So I have y plus 7 over 2 equals 3. I'm going to do a little bit of cross multiplying, move the 7 over, and we're all set. Okay, we're all set. Now we haven't talked a lot about rotation yet, and we're going to talk about that more later on. But this is, well, this is probably something that we have to visit later on. It's really not an emphasis of what we're doing here on this lesson. If you noticed how this is based on some stuff that we do in chapter 1 and earlier in chapter 2. You see how we started in the middle of chapter 2 here. But we could probably still talk about it. I mean, so just think about this for a second. Find the coordinates of the image of RHO. If you rotated the triangle 180 degrees, about point H. So my R prime, rotating 180 degrees about point H is the same as reflecting over point H. Okay? That makes H the midpoint of the segment R to R prime, which is the new point. Okay? So we can actually do this pretty easily. Watch this here. If this is the midpoint from R to some unknown R prime point, take a look at the X values. To go from -6 to 9, we had to add what? We had to add 15 to get to this midpoint. So that means we just add 15 more to get to the other endpoint. So 9 plus 15, that would be 24. And we do the same thing for the Y's. 7 to 10, well, we had to add 3, so this, of course, is 13. Okay, we're going to emphasize this more later, but this gives you a little bit of introduction into this. So if we do the same thing with O, you know, 15 to 9, we had to go down 6. So we have to go down 6 more from 9. That takes us to 3. And -8 to 10, we had to go up 18. So we're going to go up 18 to 28. And I hope you realize that H prime, if we're rotating about H prime doesn't change. It's the same. Okay. We'll spend more time on that later. But hopefully you have a little idea. This one down here, I'm not going to do this one here in the video. I will have a posted document that has the solutions, worked out. It says lines are concurrent if they all intersect at the same point. Are the medians of a triangle concurrent? So you'd have to come up with the equation of all 3 medians of this triangle, and you have to solve some couple of systems, right? And show that they all meet at the same point. Now the point's messy. You do end up getting fractional x/y values for that point of concurrency. But if you feel like messing with this and give yourself some system practice, please feel free. The solutions will be posted on Canvas on the current unit. Okay, so you can check that out yourself. All right, see ya.